All right, last thing for chapter 1, we are going to talk about rewriting equations. I need to share my screen with you guys. You'll find out. All right, people at home, can you see my note screen? Okay, cool. All right, so last topic is rewriting equations. Are we there in our packets? Yeah. Excellent. Bailey, can you take your backpack off your desk for me? It's just like a big barrier. Thank you. It's like you're hiding from me back there. All right, so if I have ax plus b equals c, how do I get x by itself? Now don't let this confuse you. Don't let this throw you off. In this equation, a, b, and c are just numbers. Okay, they just have letters there as placeholders. Thank you. So how would you get x by itself? If you just wanted to solve for x, what would you do? What opposite operations would you use, Dallas? You would subtract b, absolutely. So let's write that down. We would subtract. Oh my gosh, see, it's going crazy. Don't understand. So we would subtract b. Good. And then what would we do with a? Divide it. Very good. Then we would divide by a. Okay. So same idea, right? It's the exact same thing you would do. So we can rearrange things that have letters instead of numbers. They don't have to always have numbers. The letters are just a placeholder for a number, so we can treat them the exact same. So we're going to solve what are called literal equations, which are equations that have mainly just variables in them. Okay. So what we're going to do is determine which variable you're being asked to solve for. So do you want to get x by itself? Do you want to get y by itself? Do you want to get z by itself, right? You have to see what the question's asking you. Then you're going to still do your opposite operations. And then you're going to get the variable you're asked to solve for by itself. And we're still going to use the 2-column method here. So it shouldn't look too foreign. Okay, so remember in math, letters, they just represent numbers. We can treat them the exact same. So let's say hypothetically I had 2x plus 5 equals 11, and I asked you to solve for x. Let's do what we've been doing already. What's happening here? All right, how would you solve for x in this one, Asia? Yeah, and we could use our 2-column method too if we want, right? I'm going to show you could subtract 5 and then divide by 2. So if you know how to do that, go ahead and do that. Or you can use your 2-column method, where you put your column down through your equal sign. We still are basically subtracting over 5, right? Because our 2x needs to stay. See, look, do you see that? It just had a connection. It's been doing this all morning. Okay. Look at that. I don't even know what it's doing, guys. Well, I tried another stylus and it still just went bananas. I think it's my screen. Yeah. Look at this. We're gonna pretend like, well, I have one of those, but then they can't see it at home. Yeah. So 2x equals, we're gonna move our 5 over, make it negative, right? And then drop our 11 down. It's like on this side of my screen for some reason. It's just having, I don't know, it's having a bad day. So then we're gonna still drop down our 2x equals, and then what's negative 5 plus 11? 6. And then what would we do last to both sides? divide by 2, right. And you should get that x equals, yeah, x equals 3. Good. All right. So now, what if you had something structured very similarly, except instead of 2, 5, and 11, there were letters? We could still actually do the exact same thing. So if you look at this problem here, it says now solve for ax plus b equals c in the same way. We're going to get x by itself. So we're still going to use our 2-column method here, okay? But instead, we don't want to get numbers on the other side. We want to get x on the left, and then anything that's not an x is going to move to the right, okay? So let's just take it from left to right like before. A with the x, does that have an x attached to it? Yes. So should that stay or go? It's going to stay. We're going to drop it down, it's going to stay. Okay. Now the b, does the b have an x on it? No. So it needs to move over and become what kind of a b? A negative b. Sorry. And then the c, does the c have an x on it? It's going to stay. It's already on the other side. So plus c. Now take a look, guys. Take a look at this. Okay, look at this versus
this.
Yeah, this. Do they look really similar, like structurally? Yeah, except instead of a 2, there's an A. Instead of a -5, there's a negative B. And instead of an 11, there's a C. They're the exact same thing, except you have letters here representing your numbers, okay? So now we need to still, now the part that then makes this tricky is then you guys are used to combining like terms, right? But can you combine B's with C's? No. So they're not the same letter though. They have to be the same letter. These are not the
same number.
Because numbers are different than variables. Yeah. So for numbers, you can add and subtract any number, right? But when you have variables, the variables have to be the same. So we still want to get x all by itself here, right? Okay. So that means we have a times x. What's the opposite of multiplying? Dividing. So we want to get rid of our a, and we want to divide through by a. So we're going to divide by a. Now, if you look at the other side, though, do I just get to pick and choose what I divide by a? So if I divide one side by a, don't I also have to divide the other side by a? I don't? Okay, well, yes. If you divide one side by a, you have to divide the other side by a. Just like with a number, if you divide one side by 2, don't you have to divide the other side by 2? Yes. Except normally things are combined, right? And here my b and my c are separate. So the question is, okay, well, what do I do with that? Well, you have to divide the whole side by it, don't you? So I don't get to just pick and choose what I divide by a. If I divide the left by a, I also have to divide everybody on the right by a, which means I also have to divide the negative b by a, and I have to divide the c by a. Okay. Again, if you divide the left, you got to divide the right. All right, so now over here, my a's will cancel. And then you're actually done, guys. You just have to drop it back down. X equals, if you have a b with an a, can you combine those? No, they're different letters. Leave it as negative b over a. Not quite like this. This is just to kind of show you something. What we're going to do now will be, but it's not actually as hard, okay? So what, I know, I just kind of blew your mind. There were a lot of letters, right? But these nouns down here, there's not as much. It's just x's and y's. Okay, so take a look. We're going to solve each of these equations for y. So what that means is get y by itself, right? Just like getting x by itself. So we're going to use our two-column method here. And if it says to solve the equations for y, that just means get y by itself. So I'm going to put my two columns. And if I want to get y by itself, all I want on the left are y's. And then I can leave everything else on the other side, okay? So I just want y's on the left. So first term, it's just a y, isn't it? So if I want my y by itself, should that stay or should that go? That should stay. Okay. Now I have a negative 3x. Is that a y? No, and aren't I trying to get my y's by itself? So should that stay there or should it go? It should go and switch from a negative to a positive. Okay. Then on the other side, now we're already now on the opposite side, right? So is the 13 good to stay there or should it move? It's good to stay there. And guess what, guys? Is y by itself? Yes, we're done. That's our answer. That's all you had to do. It's not as bad. And plus we're gonna practice them for 8 of them and it'll get a little easier as you go. Okay. So now go over and take a look at 2. Super similar, right? We want to get y all by itself. So put your column. So first term is a y, right? Should it stay or go? It's going to stay. Next term is a 5x. Should that stay or go? It's going to go and become a negative. And now we're on the other side. We have a 7. Is that good to stay on the other side? Yeah. So plus 7. Bailey, do you have this written down? Okay. Do you have it as a negative 5x? Okay. Were we okay with those ones?
Yeah.
Not as crazy, right? Okay. So 3 and 4, super similar. Let's look at 3. Just kind of written in a slightly different order. So again, go from left to right. 2x. If we're trying to get y by itself, right? I only want y's on the left. So does that first 2x belong there? No, what needs to happen to it? Dallas? Yeah, move it to the other side and make it negative. All right, what about the y? It's going to stay. And then on the other side, what about the 7? It's going to stay. And guess what? Is y by itself? Yeah, we're done. Do you feel a little better about it, Alex? Okay. All right. So then last one like this, number 4. Put your column. We're trying to get y all by itself, so we just want y's on the left. So look at the first y. Should that stay or go? Stay. Negative 8x. Should that stay there or should that move? Very good, Alex. Go and turn into a positive. Now we're already on the other side. So negative 3, stay or go? It is going to stay. And then we're done with ones like that. There's one other little thing though. Asia, you have a question? Yeah. Okay. So now go to the back page of that. We're on number 5. They're not way harder, don't worry. There's one more step, right? So for the ones we just did, all you had to do was just do one thing and then you were done. These will require one more step at the end. So number 5, We're still trying to get y all by itself. So we want y's on the left. Anything that's not a y is going to move to the right. Okay, so Bailey, negative 2y, should it stay or should it go? It should stay. Doesn't want to let me write. Okay, so now 3x. Should the 3x stay or go, Alex? It's going to go and become what? A negative 3x. Good. So move it over, make it a negative 3x. And then Dallas, should the 8 stay or go? It is going to stay where it is. Okay, good. Now, with the other ones, we were done at this point, right? Are we quite done with this one? Is y completely by itself? No. What's next to the y? A negative 2. So this means we have negative 2 times y. So how would you get rid of multiplying that, Dallas? Divide. Now remember up here, if we divide one side, do we have to divide everything on the other side? Yes. So same thing's going to happen. You cannot combine 3x and 8, right? Those are, one has an x, one doesn't. They got to stay separate, but we still got to divide everybody by negative 2. So I'm going to divide the left by negative 2. And I have to divide everybody on the right by negative 2. So that means I have to divide this by negative 2 and the 8 by negative 2. Everybody has to get divided by negative 2. Right? Does that kind of make sense? Okay. So now on the left, your negative 2's will cancel and we just have y equals. Now we got some fractions, but that's okay. We've been practicing simplifying fractions, right? So if you have a negative over a negative right here, what's a negative over a negative going to be? A positive. And can you reduce 3 over 2? Like as a fraction, can that be reduced? No. So just leave it like that. 3 over 2, and then put your x next to it. Now we have 8 over negative 2. Can that be reduced? Yes. What's 8 over negative 2 going to become? Negative 4. Now, question for you, we also talked about this. When you have a plus and then a minus, do you need both of those signs? No. Remember, we always talked about that the negative is more important, right? So if you're adding a negative, you don't have to write plus a negative 4. You can just write minus 4. Yeah. It won't let me write a 4. I don't know why. We'll pretend like you can read that that's a 4. That's just what it keeps doing. So that's a 4, guys. Right, it doesn't look like one though. But we're gonna, I don't know. I can't deal with that. That's a little better. It just, I don't know why it keeps glitching like that. It's infuriating because I'm writing one thing and then it's just like glitching and writing something else. I don't know. Okay, so that's that answer. We're done with that one. Okay, so hopefully if I restart my computer later, it'll work better. So number 6, put your columns down. So let's go through. We want to get y all by itself on the left, right? So Corey, should the 8x stay or go? Go and make it a negative. Okay. So I want my y's on the left. So Jaden, should the 4y stay or go? Stay. And then Lynn, now I'm on my other side, should the 20 stay or go? Stay. And then Asia, am I 100% done? No, what do I need to do now? Yeah, divide through by 4. And if I divide my left side by the 4, I got to divide everybody on the right by 4. So I'm going to then have y equals negative 8 divided by 4. Can you divide negative 8 by 4? Yeah, you can divide negative 8. What is negative 8 divided by 4? Negative 2. Yeah, don't forget to bring your x. And then what's 20 divided by 4? 5. And now you're done. Good. Any questions yet? Is anything just really throwing you yet? Well, no, most people don't like it, but sometimes we have to do things we don't like. All right. All right, number 7. All right. Number 7, we got negative 6x plus 3y equals 9. Put your 2 columns. We want to get y all by itself, so I'm going to start calling on people at home. I am going to throw my computer out the window first, though. Oh my gosh. I need to like meditate or something. Yeah, we'll see what happens. I just need a better device, I think. So, negative 6x. Annalise, should negative 6x stay or go? Very good. It should go, and we should change it to a positive. Hannah, should 3y stay or go? Yeah, it is going to stay. Oh my gosh. Okay. And then on the other side, we have a 9. Jake Sanders, should that stay or go? Yeah, I said, did Jake Sanders, should the 9 stay or go? Well, it's already on the right? So do we want to move it to the side with the y, or do we want to leave it where it is? Yeah, leave it where it is. And then last thing for this one, Jesse, is there anything else I need to do now to make the y all by itself? Yep, by what? Yep, divide everybody by 3. All right, so that's going to give me y equals, Mason, I got to simplify this 6x over 3. So what's 6 divided by 3, Mason? You there, Mason? All right, we'll come back to you, Mason. Nick, 6x divided by 3. How can I simplify 6 over 3? Yeah, very good, 2x. And then Owen, what about 9 divided by 3? Yeah, just 3, good. Good, and that's it for that one. Okay. You live out there, Alex? Okay. All right, one more of this. And then we'll probably only do 2 of the other ones. So number 8, get your 2 columns. We got 2x minus 8y equals 6. We want to get the y's all by itself. Asia, 2x, stay or go. Goes and becomes negative 2x. Lynn, negative 8y, stay or go. Stays. Jaden, 6, stay or go. Well, so we have it on the number side, so should we move it towards the y or keep it away from the y? Keep it away from the y. So plus 6, good. And then Corey, is my y all by itself yet? Not quite. What do I got to divide by now? Yep, divide by negative 8. Okay, so we're going to divide by negative 8. On the left, they cancel. Now over here, don't you have a smaller number on top? So if you're reducing a fraction and you have a smaller number on top, it's going to stay a fraction, okay? So first of all, what's a negative divided by a negative going to be? A positive. And if you have 8 over 2, that is not 4. It's very tempting to write 4 because you think, oh, 8 divided by 2 is 4, right? But the smaller number is on the bottom, so you just have to reduce your fraction. What can we reduce both of these by? 2, yeah. So what's 2 divided by 2? 1. What's 8 divided by 2? 4. And then just put your x on it. Now, same thing over here. What's a positive divided by a negative? A negative, so we can just put a big minus sign if we want, right? And then we have 6 over 8. What can reduce 6 over 8? 2. Yeah, they're both even numbers, right? If they're even, always try 2 first. What's 6 divided by 2? 3. What's 4 divided by 2? I'm sorry, what's 8 divided by 2? 4. And then you're done. Okay. It's not the best, but it's not horrible either. Okay. So I just want to look at numbers 10 and 11, and then we're going to call it a day. I'm actually we're going to skip 9 this year. Yeah, I know. All right, number 10. The area of a rectangle is A equals L times W. Does that formula sound familiar? Area equals length times width? Yeah, area equals length times width. That's how you find the area of a rectangle. We're going to solve the formula for L. That means get L all by itself, okay? So first of all, if we're starting with A equals L times W, if we want to solve for L, don't we want L to be on the other side? Don't we want it to be on the left? So are you allowed to like take something and flip it around? Does like x equal 3 mean the same thing as 3 equals x? Yeah, they mean the same. So you can take things and flip them around. So that's actually what we're going to do first. I'm going to flip this around and make it L times W equals A instead. Because then I have then I have the L on the left, and it makes it a little easier to read. No, you do not. Only if you add or subtract them. So here, so I see what you're saying, Giles, because we switched sides. Since we switched everything, it's okay. Okay? So now we want to get L all by itself. So you can kind of think of it in your 2-column format again, right? Except there's no adding or subtracting in this one. Are we just multiplying by W? So how do you get rid of multiplication? You divide. So we are going to divide both sides by W. Again, treat it just like it's a number. Your W's on the left will cancel, and you will just have L equals A over W. Because can you combine an A with a W? No. So that's that. Okay. Number 11 is super similar. It says the formula for calculating distance is d equals r times t. That's distance equals rate times time. You might do that in science at some point if you haven't already. Solve the formula for t. So this is going to be the exact same strategy. So we have d equals r times t. Don't we want to solve for t? So t right now is on the right. Do we want to have it on the right? No, we want to have it on the left. So I'm going to take my entire problem and I'm going to switch it around so that it's on the side we like it on. So I'm going to say r times t equals d. And since we didn't add or subtract anything, we don't have to worry about our signs. We just completely reversed it. Okay. Now t still isn't completely by itself. It has what letter next to it? An r. Is that r being added, subtracted, multiplied, or divided currently? Multiplied. And how do you get rid of multiplication? You divide. So we're going to divide both sides by r. The r's will cancel, and you will just have t equals d over r. Huh? It's because I drew it cursive, because I don't want it to look like a plus sign. So d over r, and then you're done.